Welcome to this special edition of Oilfield Network News. When covering new technology stories, we were introduced to Seismos and their CEO, Panos Adamopoulos. Panos invited us to visit their corporate headquarters in Austin, Texas, where we got a first-hand look at their hardware, as well as a few questions answered about Seismos from Panos. The following is a list of the questions and the running time in the interview video, which you can use as a reference to go back to specific answers or to share the link and point others to specific points of interest.
We measure reflections and we invert those reflections for information that is meaningful to the completion engineer. And the completion engineer is interested in the geometry and performance of a stage. Geometry is very easy for you to understand, length, width, height. Performance is defined by other data points, such as the complexity of the network, the conductivity of the network, the complexity in the near field regime, in the far field regime. Those are the things that are important. So yes, there is a geophysical process included. Yes, there's always acoustic models that you have to use. You have to match your real data to your models. There's a well-known process in processing the data, and of course, all these are parts of the processing. But it all starts with the acoustics that we introduce into the system, because if you don't know what you're introducing into the system, you can't really know what to expect, right? So that's part of the equation. Then there's lots of IP and knowledge in how can I improve my signal to noise ratio. That's another very key component. There's lots of processing techniques that we're doing. We have a very advanced approach on that end. Well, first of all, we need to define which is our space, right? So we are in the space of taking real-time data for completion optimization, right? And actually, our biggest competition is do nothing. This is what most of the companies today are practicing. They use surface data, they use pressure. The data points are familiar to them. And based on that, because they have some historical knowledge, this has been going on for decades, right? They take decisions as, for what is the best next step, especially when they do stage-to-stage optimization. Hydraulic fracturing historically has been more of an empirical understanding process, a little bit of trial and error, and fracture diagnostics have not been used to the extent that they could have been used. There's many different ways for companies now to get some understanding of, what are the dimensions of my fracture? Is this a fracture system that I really envisioned when I was doing this particular stimulation design, right? The big problem with all these conventional techniques is, first of all, the footprint, right? They tend to be much bigger. There's a component of people and equipment that has to be mobilized in the field. They are sometimes disruptive to field operations, and that doesn't have to do only with the footprint of the equipment. It also has to do with certain changes that you may have to impose to field logistics, right? And then it has to do with data points and the time of delivery of that data, right? And that's where we as a company, we bring the big revolution, because our data is different and our data is being streamed real time during stimulation. So that's the very, very big difference that we bring in the game. And the other big thing I want to say is that we think that subsurface understanding, subsurface intelligence should not be a luxury product, shouldn't be a nice to have for the companies that are able to afford it. It should be part of the business. It should be a commodity. So essentially, we're bringing a product that is so modular, so plug and play, so easy to use and deploy, priced at the right price point. So in essence, we're making it a product that is to be used at every wellhead. First, let me say that the word AI is maybe one of the most heavily abused words, like across all industries, right? Everybody's doing AI.
Several days worth of
deep
learning.
Yeah, there you go, machine learning and all that stuff. But anything that has to do with data, and essentially AI is a technique on manipulating data, it depends less on the technique and mostly on the data. If data is not of good quality, that's going to give you nothing, right? So it all starts with the data. And the big problem of anything that is existing today is that typically it relies on surface or operational data, on pressure. It's nothing really unique that gives you the full picture. So yes, we're launching Seismos AI. Actually was launched this month. It's the first AI ever focused on completion optimization. But what makes it very powerful is that it combines all the available data, treatment, operational data, field data, to subsurface fracture measurements that are streaming in real time. So essentially, I'm doing things, I have my known data points, but I also have my fracture measurements that are coming in real time. All of these are blending together, and now I'm able to really find that optimal recipe, out of those hundreds of different completions variables that will lead to the optimal outcome. And I'm the one defining that optimal outcome, because the way you use an AI product is you pretty much define what you're looking for, right? So I want to optimize the extension of my system. Or I may want to optimize near field complexity, right? Or far field conductivity. So I set that up front to the system, and essentially what it does is it takes measurements, treatment data, everything lumps into the machine learning platform, and essentially it helps me do 90% of the legwork. We don't want to eliminate the human factor, so this is not a product that was built to make the frac van consultants lose their job or similar. This is to empower them, to make them spend less time on some of the basics and just be there for the critical decisions. You can't go at one well, for example, and apply AI. You need some data points. The good thing is that we don't need thousands of data points. We found that with 300 data point stages, we're good to go. But then it's also, as I said before, it also depends on the data. For example, if I got 5 wells and I do the same completion design and then apply an AI, it's going to give me nothing, because doing the same completion design across 5 wells, I'm going to get a flat response, assuming that their geology has no changes, right? So that feeds it with no knowledge for the AI platform to work on. But assuming that I'm approaching this in a more intelligent way, that I'm tweaking small little things from volumes, rates, cluster spacing, all these components that a completion engineer takes in place, then the system has all that feed that it needs to really trigger the algorithms of the platform, and then really give me some direction on what is the optimal completion design. We price at 5 digits. It's very, very clear. We're open with our pricing, and essentially we now focus mostly on campaigns. Our product is not geared towards science wells. The whole concept of a big E&P company doing a science well to get some data understanding is completely outdated. It doesn't even make sense. The E&P companies themselves are admitting so. What happened historically is a company had a very long, very heavy schedule. For the year, they would pick a month, pick a pad. They would name that the science well, the science pad. They would throw in all kinds of technologies that could give them some understanding. They would, throw in millions of expenses. Then they would hope that out of that big experiment, some data would be produced. Of course, there would be a mountain of data. They would need to hire a team, call it the integration or data, whatever team. That team would work on the data for a year. Hopefully, after that 1 year, something came out of that data. Many times, nothing comes out of the data, and data just sits on the shelf. And then with those data in place and with that understanding in place, because it's a year after, typically what happens is technologies have changed, data is outdated, they may have switched location. It just doesn't make sense anymore, right? So the whole premise of what we do is, if I have to wait 100 wells to reach my science well to make some understanding of what's going on the subsurface, I've lost the game. If I have a well schedule that is either 10, 20, 200 wells, it doesn't make a difference. I'll be producing data and streaming data out of my very, very first well. And that can't happen at a price point of $500,000, 300,000, or 1 million. It needs to be an affordable, reasonable price point. And my data needs to be relevant to what matters to these companies, which is their production end of the day. So the whole system, the way we built it, is we hook up on the well, day one, first well, we go to the next well, to the third one, and so on. We follow, in a way, the frac spread as this company is using it. So progressively, we build knowledge, right? So essentially, that's our structure, and we price accordingly. Continuously monitoring your fractures is a must-do thing, enabled to optimize completions either on a well-to-well basis or on a pad-to-pad basis, or even on a stage-to-stage basis, right? Typically, when we engage on a project with a customer, the first wells are focused on understanding what is it that I did today. Like I said, typically customers have this empirical understanding that, hey, this is how I'm stimulating my network. This is my length, width, height of my fractures. They have pretty much no idea of their complexity near the wellbore, far from the wellbore. They have no idea of other data points such as how conductive are my fractures. What is their ability to conduct hydrocarbons once I put them in production? There's data points that are missing there. The first 1 well, 2 wells, 3 wells, depends on the case, are mostly creating a solid understanding of what is my existing base design, completion design producing today. What is it that I'm getting of a fracture system? And then it becomes a sensitivity analysis. We all know that even if you land in zone, there's changes in the geomechanical properties. What do these mean for my fracture system? We get many times customers saying, you know what, I'm pretty confident, the geology doesn't change, I'm getting the same thing throughout my stimulation design. And then we see that only small, subtle differences in the geomechanical properties, very minimal ones, right, produce very different fracture systems. On the one end, you may have, long planar fractures. On the other side, you may just have complexity, lots of mini fractures close to the wellbore. So different fracture systems within the same lateral, within geologies that the customer is assuming that, hey, they're pretty uniform, but really they're not. So as I said, first 2 wells, typically the way we do our projects is understanding what we're doing, building some sensitivity analysis around the geology and how that changes, and then it becomes more of a fine-tuning exercise. Whereas I had at the beginning 1 base design, now I start having 3 base designs because I understood that in different geologies, I should have a different base design because I'm getting different fracture systems. And end of the day, because of well spacing issues, typically completions engineers are looking for some uniform fracture system in terms of fracture system properties. So in that sense, what this means is I may have to modify my base design based on the geology variations in order for me to get that uniform fracture system. And that could be uniform in terms of extension, in terms of complexity. That depends always on the specifics of that particular E&P company. So once I get that solid understanding, right, and it takes some wells, right, I understand, I do sensitivity analysis, I build a library of very useful data, right, and it's very powerful data because it shows me what is my optimal completion design, what is my optimal completion design in different geologies, what is the quantitative effect of small things that I may tweak in my design? I mean, of course, there are some obvious trends. I put more acid, I should expect some more complexity, but understanding how much of this leads to how much of that is where the big difference comes in completion optimization. So typically we start with this workflow, and then the big thing that we're trying to educate customers is once you have that library of knowledge, that library of data in place, how do you move forward? Let's say you've reached now well 6 or well 7, right? And you have a plan for 20 or 30 wells. Like, what do you do then? Then it's all about measuring compliance, right? And it's extremely important. I need to go stage by stage.
Thank you, Panos, for inviting us to visit and educating us on this new, exciting technology.